I'm going to do what you just did on high speed so that this will give you an opportunity to interrupt me and ask any questions that you had while you were doing it. But here we go. First thing we did is make a class called rect. So I'm going to come here, say class rect. There, I've made a class called rect. Now, I think a rectangle should have 2 points, one for the top left corner, one for the bottom right corner, right? Now, what if the rectangle were askew like this? Maybe it needs an angle too, and if it's 3-dimensional, then you need 3D points, but we're just assuming all rectangles are axis aligned and can only have a height and a width. Why? Because something to do. So point top left, point bottom right, or however you want to specify it. Sound good? Okay. Add a constructor to your rect class. So here I go on step 31. A constructor has the same name as the class. And let's see, it takes no parameters and initializes to have unit size. Well, let's say top left equals new point at 0, 0. And bottom right equals new point at 1, 1. Sound good? When I specify values for doubles, I like to always include a decimal point. So I'm saying 1.0 here and 0.0. My reason for that is because it reminds me that this is a value for a double and not a value for an int. It just helps avoid certain errors. So good practice. You don't have to, but I like to do that. So that's why I'm saying 0.0, even though that's equivalent to 0 and everybody knows it. That just reminds me it's a double. Now, why do I say that instead of saying top left is equal to 0, 0 or something like that? How come I can't just initialize the value directly?
We could, but then it wouldn't move around if you wanted to.
Yeah, well, the thing is top left is not a single value, it's a point, and points have 2 values in them. The only way to create a class is to use the word new. So using new is the answer. Okay. Now if I had a primitive type, like an int or a double, then I would initialize it like this. I equals 5, d equals 5.1. See, we initialize primitive types with values. We initialize class types, not primitive types, with a new object. Does that make sense? Okay, there's a big difference between a primitive type and a class type. The difference is you make class types. Java provided the primitive types for you. Incidentally, Java provides a whole bunch of class types too, but we'll talk about some of those later. Anyway, we have made a new rect here. Any questions? That's correct. Okay. Primitive types you set to a number, right, or true or false if it's a Boolean, or a string if it's a string, or a number if it's an integer. Excuse me, strings are technically class types. Talk about that later. When you make a class, you have to make a new object of that class, and the variables actually point to an object. So this is a variable of type point, and variables of type point have to point to a point object. New point makes a point object, and this equal sign is initializing TL, top left, to refer to that new object. Is that enough words to be confusing? It's the variable that's being initialized. The object is the value that it's being initialized to. Here's what an object really is. An object is really a block of memory. Somewhere in memory, you have enough space to hold a double called x and a double called y. So a point is actually twice as big as a double because it's got 2 doubles inside of it. When you say new point, you're making an object. And here we're initializing this variable to know where in memory that object is. So I'm initializing this member variable right here. And you see how the scope, based on these braces, is for the whole class. So one way of putting it is you can access TL from any method inside of the point class.
Inside those two brackets.
Yeah. Anything that's within those braces has access to TL and BR.
Okay.
And so you can access TL and BR from here inside of this rect
But you
constructor.
can't put that point TL colon into that rect.
Oh, I could put these right here if I wanted to.
Okay.
But there's
Does
a,
it matter?
it does matter. Here's why I don't want to do that. If I do that, then these go away as soon as this method is done.
Uh-huh. Oh, it can't go back to.
And I want to point to, or excuse me, a rect, to have these 2 points that last after I'm done constructing it and then when I'm going to do other things to it too. So if you put it in the class and not inside of the method, this is what's called a member variable. And member variables stick with the object. Local variables are only for the duration of the method itself. That's actually a really important question. I'm glad you asked that. And that's something we need to emphasize a little bit.
Where to put stuff.
Yes, that is a perfectly valid thing to get hung up on. With programming, there's a bit of bootstrapping that needs to happen. You can't program unless you know all about it. And you can't possibly know all about it until you've done a little bit of programming. So I'm sorry, we're trying to come up with simple examples and we're just going to work through a few of them until things start to stick. And then we'll move forward. That's about the only way I know how to do it. So the answer to your question is member variables last because they're actually stored in the object. Local variables are very temporary. Okay. Instantiate a rect object in your main method. So I'm going to come down here and say rect r equals new rect. And let's see how many parameters my rect constructor takes. None. So I don't have to give it any parameters. There we go. I did it. Good so far? Okay. 34, add a method that enables you to stretch a rect object horizontally and vertically by adding specified values to its width and height. I bet you a lot of you didn't understand those instructions. Well, I wrote them this morning and I was in a hurry, so sorry. But let's make a method called stretch. And in order to stretch this thing, we want to specify how much to stretch it, right? Double horiz and double vert. I'm going to stretch it horizontally and vertically by some specified amount. And now how do I want to do that? Those of you who looked at the answer, here's what I did. I said bottom right dot x plus equals horiz, bottom right dot y plus equals vert. What does that mean? I could have. So let's change it now to br.x plus plus, br.y plus plus. What would this code have done?
You would just add one value in.
Yeah, this makes the rectangle get bigger by 1. And if I called it 5 times, it would get bigger by 5, right? Okay, how does that differ from this code?
You're adding the value of the...
This, I add however much I want to x and however much I want to y. So this is more parameterized. This is letting me pass in the values. I could pass in a 1 for horiz and vert, and then it would grow by 1, just like the other one.
Where did you... Okay, you haven't defined horiz and vert, though. You'll do that down below.
I have not.
All the functions?
In fact, that's kind of what a parameter is. A parameter is saying, here's something I'm going to need, but I don't know where it's coming from yet. Whoever calls it is responsible to provide 2 values.
And then you would write stretch, parentheses, 2 and 4, or something like that. Okay.
Yeah. Now, adding to the bottom right corner is not the only way to stretch a rectangle, right? You might want to scale it, and I could say that horiz and vert are actually scalars, and I could do a little math to calculate the difference between the 2 corners, and I could multiply it by something, and I could move both points equally, and there's a lot of things you could do. And there's no reason why this is the right thing to do, except that my instructions said to do something, and that's what I picked. So Why am I stretching it? Because darn it, we've got to do something. And that's why I'm stretching it. Okay. Why did I pass 2 parameters? Because I needed 2 parameters so that I could stretch by that amount. Does that make sense? Basically, you add parameters when you don't really know where that number is coming from. And the caller has to provide a value.
What if you oh wait,
Okay. 35. Instantiate a second rect object in your main method. Stretch it and print its area too. Okay. So rect R2. Let's call him R2D2 just to be funny. By the way, in the answer I called it rectina and rectifer. That's me being funny. Those are not actually built-in Java names or anything. You can call your variables anything you want, but you should use meaningful names if you can. And R2D2 is not at all meaningful. So this is an example of me giving you a bad example.
Are there anything we put in there that are not allowed?
You can't have spaces because then it doesn't know when your names start and stop. And you can't have periods or minuses or pluses or times or divides because those are all, they have meaning. Or parentheses. Basically, you can use alphanumerics and underscores. Letters, capital letters, numbers, and underscores are all that are allowed in variable names.
you can't start with a number, right?
Used to couldn't, I think now you can. Error, not a statement. 6 R2D2. Now I remove the 6, build. The definitive answer is no, you cannot start with an answer, a number. Okay. There are languages that allow your variable names to start with a number. Java is not one of them, as we have just determined. Okay, I'm going to stretch R2D2. Now let's suppose I just call it like that. What do you think will happen? It'll yell at me because error cannot find symbol stretch. Why can't it find that symbol? It's right there. That's a really confusing error message because the problem isn't that it couldn't find a symbol, it's that it couldn't find a method named stretch that took 0 parameters. So that's Java's way of not expressing itself very clearly. The symbol that it couldn't find is a variable named R2D3. Oh, I'm wrong. It really couldn't find R2D3 because it's R2D2. Now we build again. Error. Method stretch in class rect cannot be applied to given types. R2D2.stretch. Required double double, found no arguments. Does that sound meaningful to you? After a long time of programming, these messages will start to become clear to you. And when that happens, you'll know your brain has started to change and you're a weird person. But the thing is, there are only 100 different error messages. There are millions of ways of expressing everything in English. So it doesn't take too long before you'll start to realize that you can comprehend this gobbledygook. I encourage you to actually read the error messages and see how they correspond with what you did. You'll become a better programmer faster if you read the error messages. Okay? What it's telling me is, hey, you forgot to provide 2 parameters. See how stretch requires 2 parameters? Let's give it 2. Let's stretch it by 3.0 and 2.0. Sound good? So I'm going to go 3 units wider and 2 units taller.